Hello and welcome to today's lesson, Solving by Elimination. Now this is another algebraic method of solving when you have a system of linear equations. We've seen substitution. I'm now going to show you elimination. So I've got an example here ready to go where I have two linear equations and I'm looking for the solution. Now this is about as nice an example for this method of elimination as you can get. So let's show you how this method works. When I look at my two equations, I notice something really cool. If I add the two equations together, I get 2x's plus 1x is 3x's. Then I get positive 5y plus negative 5y. They kind of kill each other off. So there are no y's. And then over here, I get negative 6. So I got this nice little equation of 3x equals negative 6. If I divide both sides by 3, I have x equals negative 2. Well, isn't that quick? Really, really nice. So this is a really good method. I'm not quite done. I still got to figure out what the y value is. So I now just pick one of these equations. Doesn't really matter which one. Say I use the top equation. And since I know that x is negative 2, I'm just going to plug in where the x is, the negative 2, and figure out what the y value would be. A little bit of algebra here. So let's have a look. So I get negative 4 plus 5y equals 26. So I'm going to add that 4. To get rid of this negative 4, I'm going to add 4 over to the other side. And that leaves me with 30, and then I'm going to divide by 5, so y equals 6. So there's my solution. This would be the point of intersection if I graphed the two lines. So that's the method of elimination. Now I'm going to clear the screen and show you a slightly more complicated example because they're not always going to be quite as nice as that one was. Okay. So my next example looks something like this. 4x plus 3y equals 10. And my other equation is 5x minus 2y equals 1. So if I run into this equation, this system of equations now, and I just try to add them up, it doesn't do me any good, because what you'll get, and I'll just show you here for a moment, what you get here would be 9x's plus 1y equals 11. Now, the problem with that is I didn't get rid of any x or any y. I've got a third equation now, but I still can't go ahead and solve it. So as nice as that was, it didn't get me anywhere. So kind of useless. So it's important with elimination, before you start adding up your equations, you want to make sure that either the x's or the y's are eliminated. So it means I'm going to have to doctor these equations a bit first. So what I'm going to do, I'm going to times the top equation by 2, and the bottom equation here, I'm going to multiply that by 3. Now here's why I'm going to do that. So the top equation now looks like this. I have 8x's plus 6y's equals 20. Okay. In the bottom equation, I'm going to multiply everything by 3. So I get 15x's minus 6y's, and that equals 3. Well, now look what happens when I go ahead and I add these together. I get 23x's, which is nice. But here's where it's really good. 6y's minus 6y's kill each other off. They are gone. They've been eliminated. And then on the right side, I get 23. So really easy to solve now. I'm going to divide both sides by 23. X turns out to be 1. So sometimes you got to doctor up your equations a little bit first so that something cancels, something disappears. Once I've got my x solution here, or if it happened to be a y solution, then I can go back to either of the original equations, and I'm just going to plug in that x is 1. So I'm going to take my first equation here, put in a 1 for that x, and then solve for y. So here we go. 4 times 1 is 4. So I'm going to take 4 away from both sides, and that leaves me 3y equals 6. Then I'm going to divide by 3, and there's the y solution. Y is 2. So here's my combined x is 1, y is 2. There's my solution, all done. And with that, I am going to call it quits. So we're going to catch you later.